Hi everyone, myself Mrs. Afroz Pathan. I'm an assistant professor in Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Sciences, Vistas. My topic is electrophilic aromatic substitution, especially nitration of benzene. Coming to the contents of the topic. So we are going to discuss the introduction about electrophilic aromatic substitution, its general mechanism and in depth about nitration mechanism, and we are going to conclude with a summary and a quiz. So, electrophilic aromatic substitution. It is a chemical reaction in which the hydrogen atom or functional group which is attached to the aromatic ring is substituted with another functional group which should be an electrophile. So this we can easily explain through a reaction. So if you see the benzene ring, each corner of the benzene will be having one hydrogen. So that hydrogen it may be replaced with the electrophile and it will produce an electrophilic substituted product which is shown on the right hand side. Types of electrophilic aromatic substitution. Generally, we will have five types of electrophilic aromatic substitution: halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. All these reactions are clearly seen that the hydrogen or any other functional group which are present on the benzene ring, if it is replaced with halogens like chlorine and bromine, it is called as halogenation. If it is replaced by nitro group, it is called as nitration. Replacing with bisulfite, sulfonation. And if it is replaced by alkyl group and acyl group, they are called as Friedel-Crafts alkylation and acylation respectively. So the name of the scientist Friedel-Crafts was given for the invention. Coming to the general mechanism. General mechanism of electrophilic aromatic substitution involves three steps. One is formation of electrophile, second one is electrophilic attack, and third one is deprotonation and to form the substituted product. So in step 1, so formation of electrophile. Generally, if you see any reagent can be divided into two polar compounds like E plus and Nu minus. Generally, E plus is considered as electrophile. Electrophile is a species which is having deficiency in electrons and it will allows to attack on the compounds which are electron rich. So that's the reason in step 2, the electrophile which is not having electrons, it will attack on the benzene ring which is an electron rich compound because of the presence of the 3 double bonds and it will form a pi electron cloud. So electrophile will attack on the benzene ring. When it attacks on the benzene ring, it will attack on the same position where hydrogen is attached and it will produce as a carbocation. Why? Because electrophile doesn't have the electrons, so it requires the electrons to form the bond with carbon. So that electrons will be taken from the pi electron cloud of the benzene. That's the reason as it is taking the electrons, your benzene will get positive charge to produce carbocation. In step 3, whatever the nucleophile which is formed in step 1 will be considered as a base and it has the ability to abstract the proton from the benzene ring. So when the proton is being removed, the bonding pair of electrons which are present between the benzene and the proton will be utilized to reform the aromatic ring. So those two electrons which are present between carbon and hydrogen will go inside the benzene ring and it will again form the double bond to restore its aromaticity and also resulting in its substituted benzene. Now coming to nitration. So nitration is one of the example of electrophilic aromatic substitution. So benzene, when it is treated with nitric acid and sulfuric acid, generally considered as nitrating mixture, when this is done, the benzene will be replaced. Benzene is able to replace one of the hydrogen into nitro to produce nitrobenzene. So this is nothing but nitration reaction of electrophilic aromatic substitution. So this also involves three steps. In step one, generation of electrophile. So when you are going to treat concentrated sulfuric acid with nitric acid, concentrated sulfuric acid acts as a strong acid and it will donate the proton to your HNO3. It serves as a base. So and it accepts the proton and this we can see as an acid base equilibrium. So when protons are transferred, this may lead to an intermediate ion and also HSO4 minus. The lone pair of electrons which are present on the oxygen is given to the nitrogen, resulting in the removal of water molecule as H2O and then a nitronium ion that is called as NO2 plus is formed, which is nothing but our electrophile and highly reactive species. So in step 2, The nitronium ion will attack on your benzene ring and it will form an carbocation. So, attack of electrophile results in the formation of sigma complex or adenine ion in which one of the carbon is getting positive charge. That's the reason it is called as carbocation or sigma complex or also called as adenine ion. This adenine ion will get stabilized by its resonance structures. So when electrophile attacks, the first position contains a bonding pair of electrons between C1 and C2 were used to form the bond between C1 and the electrophile. So the carbocation is formed at the first carbon. And to neutralize that carbocation, the relocation of pi electron will take place. The double bonds which are present between the carbon 5 and 6 get shifted between carbon 6 and 1. Then the carbocation which is present at the first position will be shifted to C5 position. Similarly, to neutralize that C5 position, the double bonds which are present between C3 and C4 get shifted to C4 and C5. And during that, the carbocation which was present at C5 position, now it will shift to C3 position. So there is a continuous deregulation of carbocation and also double bond, which is generally done to maintain the stability of aromatic character within the ring. So this type of resonance structures altogether it is called as sigma complex, and also the hybrid of the sigma complex is shown where the positive charge is shown with a dotted line as it is being shuffled between all the positions of benzene. Coming to step 3. Step 3 is removal of your proton to form carbocation. So, generally what will happen, as I said, the nucleophile which was present in the step 1, it acts as the base and it has the ability to abstract the proton from the benzene ring. So, when it is abstracting the proton from the benzene ring, the first carbon which is attached to hydrogen, okay, which is attached to hydrogen, only hydrogen will be known as H plus. So the bonding pair of electrons between the carbon and hydrogen will go inside the aromatic ring and it will form bond again to regain the aromaticity of benzene. And finally, it will produce a substituted product that is nitrobenzene. Generally, nitrobenzene is having special importance in organic chemistry because nitrobenzene is useful for it is an essential precursor for the synthesis of aniline. Aniline is a starting between for a number of organic compounds because whatever the functional groups which are able to substitute in benzene ring can be easily prepared from benzene by distillation and coupling reactions and even Xanware reaction. So by using these reactions, any number of aromatic functional group substituted products can be easily prepared. Next quiz time. We are going to discuss few questions as it will be useful for understanding the basic concepts of nitration. So what a nitrating agent acts like? So nitrating agent generally produces NO2 plus, so it acts like an electrophile. Then the density is least at which position? Generally, if you take benzene is a is a symmetric molecule. So wherever if you see each corner is almost similar. So the electron density is present equally at all the places. But if you consider any mono-substituted benzene, so due to presence of that substitution, there will be difference in what you call density or electron density on benzene. Generally, if an electron releasing substituent is present, then the density will be higher at ortho and para position. Then coming to the third MCQ, that is NO2 produces which effect? NO2 is an electron withdrawing group. So as it withdraws the electrons from the benzene and it will get the negative charge. That's the reason it is called as minus I inductive effect. So option 2 will be the correct one. Then coming to the next question, in which position does the nitro group enters? As I said, if it is simple benzene ring, generally it will go to all the positions. But if it is a mono-substituted benzene, so generally the nitro group will go on to the position which will be who will decide. That means the already substituted group which is present on benzene that will decide where the nitro group will go. If it is an electron releasing group, the nitro group will go to ortho para position, whereas if it is an electron withdrawing group, it will go to the meta position. But if it is simple benzene, it may go to any of the positions. Then last question, nitration is an example of, generally we are studying the topic under electrophilic aromatic substitution. So option C will be the correct one for this question. So these are the references from where I got all the concepts. Thank you, one and all.